Hello everyone and welcome. Today, we are diving into a fundamental concept in gas chromatography, the response factor. Have you ever wondered why two different compounds, even at the same exact concentration, can give you completely different peak sizes on your chromatogram? The answer lies in the response factor, and understanding it is absolutely crucial for accurate quantitative analysis. Imagine your GC detector is like an audience watching a talent show. Some performers, which are our chemical compounds, are naturally more charismatic and get a huge applause, which is a large peak area. Other performers are quieter and get a much smaller applause, or a small peak area, even if they are all putting in the same amount of effort, meaning they have the same concentration. Your detector simply does not see or respond to every compound equally. This is because a compound's chemical structure, how it behaves in the detector, and its physical properties all influence the size of the signal it generates. This means we cannot just assume that a bigger peak automatically means there is more of that substance. We need a special tool to correct for this difference in detector sensitivity for each compound, and that tool is the response factor. So, what is it exactly? A response factor, often abbreviated as RF, is a unique value that connects the concentration of a compound to the detector's response for that specific compound. Think of it as a personal conversion key. It allows us to translate the raw signal from the detector, which is the peak area, into a much more useful and meaningful value, the actual concentration of the substance in our sample. It's important to remember that every compound will have its own unique response factor for a specific detector running under a specific set of GC conditions. To calculate it, you first need to prepare a standard solution. This is a sample you make with a precisely known concentration of the compound you want to measure, which we call the analyte. You inject this standard into the GC and record the resulting peak area from the chromatogram. The formula is then very simple. The response factor equals the known concentration of your standard divided by the peak area it produced. For instance, if your standard has a concentration of 100 parts per million and it gives you a peak area of 200,000, your response factor is 100 divided by 200,000, which is 0.0005. Once you have this number, you can analyze your unknown sample. You run the unknown sample using the exact same GC method. You then measure the peak area for your analyte in that unknown sample. To finally find the concentration, you just multiply the peak area from your unknown by the response factor you calculated. So, if your unknown sample gives a peak area of 150,000, you would multiply it by 0.0005 to find that its concentration is 75 parts per million. This whole process makes the response factor the essential bridge between your instrument's raw signal and the real-world concentration of your sample. Thank you so much for watching. If you found this video helpful and easy to understand, please give it a thumbs up and consider subscribing to support the channel. It really helps us create more content like this for you. See you in the next video.